Let me do this integral by two methods. These are very good methods. Now, in the first method, I start with substitution. Let x be pi minus t. So my integral becomes pi minus t, right? Sine pi minus t is sine t. So this is sine squared t minus sine fourth t. And dx is negative dt. Right? And the boundary has been changed to minus pi to 0. Now then I use this negative to switch the boundary becomes 0 to pi. And this time this one is a pi, right? Pi square root minus sine fourth t dt. And this one times this one is exactly the same as my target integral because t and x just dummy variables. So minus I. So my I is found equal to half pi integral from 0 to pi square root half square sine square t minus sine fourth t and dt. Right? And this one is a sine squared times the bracket 1 minus sine squared. So 1 minus sine squared is cosine. So it becomes both can be taken square root out, right? It becomes sine t and the cosine t and dt. Since they are taking out the square root, so we are taking absolute value. Yeah. Now then I'm using substitution again. Let t be half pi minus x. So this one becomes half pi integral the absolute value sine t becomes cosine, cosine becomes sine. So it's end up with the same thing. And negative, this has been changed from negative half pi. Now then I use this negative to switch the order of boundary, so this becomes half pi from minus half pi to positive half pi. Absolute value is sine x and the cosine x and dx. So this one is equal to 1/2, right? So it becomes a quarter. Yeah, quarter minus and sine 2x. Good. Since this is even function, because it's always positive, so we can change this one to from 0 to that and double it, right? Becomes from 0 to pi. Yeah, it's just sine 2x. Because this is even function. What I'm doing, this is half. Yeah, from this one to this one becomes 0 to this and double it. Now, since sine 2x in this interval from 0 to half pi, it's always positive. So I don't need absolute value. Right? This one is equal to 0 to half pi sine 2x. Because it's always positive. Now this one is easy. This is half pi. This becomes this is the cosine, and times negative half. Yeah, because this is a negative sine 2x times half becomes this. So it's end up with a negative quarter pi and cosine 2x from 0 to. Yeah, this is negative quarter pi. Cosine pi is negative 1, right? Minus cosine 0 is 1. So the result is half pi. Yeah, good. Now, second method. Second method. Second method, I start, well, first changing this one to, this is sine square multiplied by 1 minus sine square. This is cosine, right? So times sine x and the cosine x. Yeah. Then I split this one into 2. From 0 to half pi x sine x cosine x dx plus from half pi to pi sine x cosine x. In this interval, cosine both sine and cosine are positive, so I don't need the absolute values. Right? This becomes x sine x and a cosine x. In this interval, from half pi to pi, sine is positive, but the cosine is negative. So I choose negative cosine. X sine x cosine x dx. Yeah. Then I can simplify into, this becomes 1/2 right? Cosine. This is sine 2x right? Dx. This one becomes 1/2 from half pi to pi x sine 2x dx. Yeah. See, these two integrals, they have the same integral function, just the boundaries are different. So I just need to find the antiderivative. I can finish these two definite integrals easily. So let me find this antiderivative. Then I can finish both of them easily. Now this definite integral is not difficult to do. This one is equal to x d cosine 2x. This one is a negative sine 2x times 2, right? So I multiply negative half, then it's making them equal. Yeah, and then I can use by parts, UdV, right? So this one is negative half UV, U times V minus VDU. V is this, du is a dx. So this one is equal to a negative half cosine 2x plus, this integral is a half sine 2x, right? So it becomes a half times this one is a quarter sine 2x. Yeah, plus 0. So this is the antiderivative of that. Then I substitute this one here and there. I finish my integral. So my integral I is equal to 1/2 of this is equal to 1/2 times this integral, which is using this antiderivative, right? This is minus half x cosine 2x plus 1/4 sine 2x. Yeah, from 0 to half pi minus 1/2 multiplied by this antiderivative, which is this, minus 1/2 x cosine 2x plus 1/4 sine 2x, right? From half pi to pi. Yeah, from pi to pi. Then I get an I, right? So this one times this one is negative 8th pi times negative 1. And put a 0 here. X is 0, right? This is x, so it's a 0. And then this one, you put it there, it's a 1/4. Cosine is 1, right? So it's a 1/4. That is this one. This is this one. And plus 1/4. Then this is a pi. This is 1/4, right? One positive 1/4. This is pi. This is pi. This is 1 minus 8th pi, yeah. And minus 1. Yeah. Wow. So it's end up with half pi. Well, it's just some calculations. But anyhow, this is a very good two methods to solve this integral.